Welcome team to the CISSP core concept. We are going to talk about CISSP objective number 3.4 in this particular section. Since the questions are more, we are tagging it into two parts, 1/2 and 2.2. And with that said, let's go and practice some questions from this. The first question is on your screen. Okay, so let's validate this question, right? This particular concept says in a computer system, the TCB should be minimized to reduce the attack surface and enhance security posture. Now, what is TCB first and foremost? So, a TCB, let me change the marker. The TCB is a combination of all hardware, software, middleware or firmware, right? Which actually helps you to execute the programs in a secure way, which helps to execute the system in a secure way. And the particular concept is saying that TCB should be minimized to reduce the attack surface. Yes, very much. The lower it is, the smaller it is better that the particular TCB itself, the exposure area is less. Because TCB is the most critical part of the operating system, not only operating system, the entire system, sorry. So it includes operating system, kernel also, it will also include the basic input output system, the core component of it. It will also include if there is a hypervisor or kind of middleware you are using. It will also include any kind of other hardware as well which we are using. So it will be a combination of all. So very much you can tag it as a true statement. But the core concept which you have to focus here is what is TCB. So you should be clear about this, right? TCB is a combination of hardware, software, firmware, whatever it is, which helps to execute the computer in the most secure fashion. That's your TCB part. Okay. With that said, let's go and practice the next question. Okay guys, the question says the trusted computing base TCB consists of both hardware and software components responsible for enforcing security policies and ensuring the integrity of the system operations. I think very much true. There is no brainer in this. We have already discussed about this. So all combination of hardware, firmware, software component, whichever is coming is under TCB, right? Only thing is, this is not entire thing. This is the core part of that particular thing which helps you to execute the environment in a secure way. The next question on your screen. Hey guys, sorry, I did not answer this, right? So this particular question is true, actually, very much a true statement. Okay, let's go to the next one now. Okay guys, let's talk about this question, right? This question says in the system mode of CPU operation, the process has unrestricted access to all system resources and can execute privileged instructions without restriction. So first thing we need to understand that we need to protect the TCB, and one part of TCB is your hardware also. In hardware, we think about CPU, memory, storage. So let's talk about CPU here, and when we want to protect the CPU operate in two modes. One is called as user mode, or we call as problem state. It also get executed in supervisory mode, or you can say admin mode, or you also can, there can be different names to this. My idea for putting this name is don't get confused. So here they say it is in system mode. So system mode is nothing but supervisory mode. What is the difference? When a particular process get executed through the user mode, when the CPU is in user mode, the particular process will have very limited access to the other processes or other instructions, other CPU instructions. So any kind of untrusted process has to go through in the user mode. But when the process is more trusted, let's say it's part of your kernel or everything, then we execute the system, we execute that in the system state or supervisory mode. that is where you get access to more CPU features, right? But it does not mean to say that the processor has become unrestricted access. It is not unrestricted. End of the day, the CPU is getting managed by the CPU, by the operating system kernel, which still will have some restrictions, right? Otherwise your CPU will become whatever they want. So that is something we don't want to happen. We will give more access to the CPU instructions, but we will not give unrestricted access. That's the point. So that is how we keep the system secure. So based on that, we can call out as a false statement. With that said, let's go to the next question. Okay team, let's talk about this question. The question says the user mode of CPU, right, operation provides direct access to all hardware resources. Not at all. I think we just discussed this, right? In the user mode, the access is very limited to only specific instructions. And just to make sure you don't get confused, user mode is also called as problem state as well, right? So that's the concept. With that said, we will tag this particular question as false because it's not right, and we will proceed to the next question. Hey team, let's talk about this question and very important concept from the exam perspective. It says address space layout randomization, ASLR, is primarily effective against code injection attacks but does not provide protection against other type of memory related vulnerabilities, whatever. Like next, that's not right. The ASLR is a, you can say, is a overarching concept which makes sure that any kind of process which is sitting on your particular RAM do not have access to the, you can say, absolute memory, or you can say the physical memory address location. It should not be able to find out the real address, real physical address of the memory location, because that can lead to you can say that can lead to privilege escalation. So what we keep doing is, when there is a untrusted process, right, there is a low trust process, we just give them relative address. We don't give them the original full access. And what will happen is, this relative address also will keep changing. Otherwise the attacker may devise some method to overcome the restriction, right? So that will keep changing, and that is why the name address space. That means your physical random access memory, physical address, layout, the particular layout, the indexing, the way the addresses has been defined, that entire layout is getting randomized. So that is called as ASLR. This ASLR is very important to protect your system, and that is also as a inbuilt feature in your entire memory. Okay, so that's another concept which you should understand, and based on that we can safely tag this particular question as false, because it provide protection against other type of memory related vulnerabilities as well, whatever listed, right? The next question. Okay team, let's see this question, and this says secure boot only applies to operating systems and does not extend to other firmware or bootloader components. So first thing, let's talk about what is secure boot. So in many modern hardware, you might have seen something called as UEFI feature, right? It is nothing but a bootloader. It's a firmware which is kind of you know, a kind of secure booting process, which makes sure that whenever you are starting a particular process, it will first do a self check. It will first do a self check to see if an attacker has not done any changes to the hardware and the firmware within that particular hardware, and based on that it will validate if your hardware is good to boot. So it's a new security feature which has come up, and that is why it is called a secure boot. So your system is started in a secure way, because there are some boot related viruses as well, or malware as well, which will go and sit in your bootloader, and the moment you start it, then the bootloader will also start, or your particular malware will also start, and you will not be able to clear this. So that is where this particular concept. Now it says secure boot only applies to operating system and does not extend to other firmware and bootloader components. Not at all. It is trying to make the entire booting process in a very secure way. And obviously operating system will come into picture, because when you switch on your particular system, the first thing which is happening is called as post check, right? It will check for post that all hardware is intact and other thing. Then it will point you to the bootloader, and the bootloader will pick up that particular file from the operating system and start in a batch way, start loading files to the entire RAM, and then you see your login screen. That is how you see your login screen, right? So that is why this particular concept can be called as false. With that said, let's go and talk about the next concept. Okay team, let's review this, right? It says secure boot relies solely on cryptographic signatures to verify the integrity of boot files. And this is very much a true question, because in case of whenever you are booting your system, right, and the particular system has to validate the the security of your hardware as well, right? So what it does, it generates a MAC address, it generates a hash address of the entire thing, and then that is digitally signed, so that you are able to validate your entire you can say integrity of your entire hardware. And then if there is, let's say, a bootloader file, that particular bootloader file also will be digitally signed, so that particular digital signature is verified to address it, and in that way we are very much secure. Okay, yeah, there is no unmodified unauthenticated you can say modification to the file, and that's very much true concept. So that is why we can tag it as a true concept here. With that said, let's go to the next question. Okay team, let's talk about this question. The question says, in OS ring architecture, ring 3, also known as user mode, has the highest level of privilege and direct access to the hardware resources. Is that true? No. I think if you don't have any idea, let's talk a little bit on the ring architecture as well. So the ring architecture is like this. There will be core ring 0, where your most trusted part of the kernel will stay, right? So you can say it is ring 0 kernel. Then this kernel may have some external dependency and kind of drivers which will be part of ring 1, and then ring 2, and then ring 3. So 0, 1, 2, 3. Okay, the less trusted process, the outer we go, the trust is going down. The outer we go, the trust is going down. So whatever applications you download, right, for on your system, for example, you have downloaded this Teams software to come on to this particular call, right? So this particular Teams software is it is sitting here in the most untrusted you can say zone. If this particular Teams has to do certain modification or something, or has to access a particular process which is on a higher trust level, it has to go through multiple layer of validation out there. And that is what the question is asking for. In OS ring architecture, the ring 3, which is actually the last one, okay, also known as user mode, has the highest level of privilege and direct access to hardware resource. No, it is false. It has the lowest level of privilege, and with lowest resources it will have access, and again it is not called as user mode. The entire thing is wrong on this particular page, and that is why you can tag this as a false statement. And with that we will go to the next question. So let's go to the next one. Okay team, let's go through this question, and it says OS ring architecture is a security model that follows or allows applications to run at different privilege level, with higher privilege levels having greater access to system resources. Very much So the more inner your process is, the more access to the system resource it will have. Normally your kernel, your security kernel, your reference monitor, all of those kind of things, they are part of ring 0, and all other untrusted process will be then slowly going out based on the level of trust. Now these particular parameters what you see are nothing like, there is nothing kind of a parameter, but this is more of a conceptual thing. So this concept is, these particular parameter is nothing but a trust level, you can say, representation here as part of the OS architecture, right? I think now you are thorough about the ring architecture, and that is why we will call this particular question as a true one, because that is very much true. The statement is true. With that, sir, thank you very much for joining me for this particular session. It was good. Let's now go a step deeper into this in part number 2. I think we have the part number 2 also coming up.